So, my name's John Oliver. So, I'm a principal developer at Microsoft. I've primarily been working on performance tooling for Java at Microsoft, but recently I've been working on Semantic Kernel for Java for about the last year or so. And just been asked to come and give you a sort of quick intro to Semantic Kernel, what it can do for you, and how to use it. So just going to go quickly into sort of what we define by intelligent apps, what you can sort of do with AI and with Semantic Kernel, go over Semantic Kernel itself, some of its features, and then wrap up with links to some other resources and some demos of Semantic Kernel's usage. So, first of all, what are intelligent apps? So, intelligent apps are effectively apps that you are utilizing AI and embedding AI into in order to improve the productivity, improve automation, and be able to respond to situations that you don't necessarily have an explicit rule about responding to, but making it more flexible for the end user. And also ability to derive greater insights into your data. So examples that you've almost all certainly used by now, these sort of various co-pilots and chatbots that allow you to do much more natural conversations with AI and data, with your data, rather than just sort of typical keyword style search that we've been used to in the past. Applications that are much more able to interpret from natural language what your intention is about things. So here, for instance, we've got a typo in the question that a user asked, but the AI still understood the intent of what the user wants, but then interpreted it and gave them a correct answer either way. So as I say, examples of what we can do. Querying with natural language. Don't need to be some kind of expert on how to get the right query. We can do AI-powered aggregations, so summarizing text, extracting action items out of it, identifying people's intent, abusive text if you want to censor that or redact it from user content. Can allow you to manipulate your data and allow users to manipulate their data, again, using natural language. So don't need to necessarily code an entirely complex UI to allow a user to describe how to change their data. We can also do things like defining business rules. So if we give AI a set of rules to follow when interpreting or performing its actions, you can figure out how to go about applying those, and I've got some examples later of a sort of rules-based system where you can just, in natural language, define a set of rules and the AI will go off and obey them. So there's typical app scenarios, customer assistants, chatbots. You can have HR chatbots that I'll show in a minute. Things like if you put user manuals, users can search your user manuals and ask questions about how to use your systems. You can use it for managing business processes by defining various rules. Again, don't need an expert user to define them. You could define them using natural language. And as I said before, we can do sort of content management by figuring intent and different types of language. With data transformations, we could do things like translating into various languages or time zones, converting into currencies, or just does it without the necessary explicit method of encoding it in your application. So, Semantic Kernel and how it can assist you integrating AI into your application. So, it's a library for integrating AI services. So it's for Java or really any JVM-based application. Well, I've got examples working in Kotlin, works great. It effectively does the Java to AI, AI to Java boundary to calls. So it helps you build up your prompt and make requests into AI services, and then helps you pull that data back, parse it, figure out how to interpret that data, and in some use cases, it can actually call your Java functionality. So if you've got a method written in Java, it can invoke those functions in your Java language, in your Java app. And again, I'll show some examples of that later. We also, it provides a templating language for helping you to build up your prompts, and also a schema for defining the various settings that you need when you call into AI services. When you call AI services, there's lots of parameters like temperature and stuff that you got to set. We sort of define a method for you to be able to set those settings. It also is cross AI. So at the moment, although we've been sort of primarily focused on OpenAI, we are currently working on Hugging Face integration, I think Mistral and Gemini integration. And ultimately, our goal is going to be that you'll be able to switch out services, mix and match different AI services within a single application, perhaps depending on which is giving you the best results or the best price. And this should all be possible without making code changes. You can effectively just sort of configuration change to say, well, we want to use this service or that service. But hopefully your prompt should work irrespective of the service. We also provide annotation framework. As I said previously, the AI is able to call into your Java application, invoke Java functions, and we provide an annotation framework that allows you to be able to describe your Java functions to the AI, so it can then figure out if it needs to invoke them. Again, got some examples of that later. And then got the link to the GitHub project there. So we are cross-platform, so cross-language. We have a .NET, a Java, and a Python implementation. So the Java has recently gone version 1. And the idea here is, again, that you can take the prompts you write and take them into any language, and they should work the same across any language. So if your developers perhaps want to prototype in Python and iterate in Python to develop your prompts, you can then just copy those prompts over, those files over into your Java implementation. They should produce the same results. And again, I've got a link to the sort of supported languages and the various features that we support. So, just going to do a quick demo of our customer assistant, which is an example of a HR application that can do the sort of typical talk to your data. There we go. Yeah, talk to your data sort of style chatbot, where here you can ask it questions like what happens in a performance review, goes off to your database and pulls back answers, and then links to the PDF, which is where it got the source of information in order to generate its answer. Then go and do follow-up questions, because it's a sort of back and forth, so you can do now a question of who will conduct my performance review. Again, goes to the database, pulls back the relevant information, and just answers it with the supervisor will conduct your performance view. And again, links to the PDF that is the source of that information. So this is something where this is a pattern that a lot of people want to do, which is taking the information from HR documents or user manuals, that kind of thing, write them into a database where we can do searches on those databases to find the most relevant information for answering a query, bring it back, put it into a prompt, and then the AI can then use that information to answer a question. So this example is using the Azure Cognitive Search, which is now called, sorry, is that, there's no joke. Okay. Search AI, sorry. For its searching, for storing data and retrieving it, but you could use any database or like Mongo, SQL, whatever, to store this data. So, Semantic Kernel itself, just so I'll go through some examples of the syntax of how you go about building up these applications. So, for OpenAI example, we first need to build up a client that's going to talk to OpenAI, where it will then, you just set the credentials and the location it's going to talk to. We're then going to do text generation. So that's just where it's completing a prompt with text. So similar to in the previous example where it was just generating textual responsive. We then add a service into a kernel and build up our kernel. So once we have our service in a kernel, it can then be utilized by any function that gets called on that kernel, that if it's decided that it needs to do text generation, it'll find that service and then use it. So how we actually go about running a prompt. So first of all, define your prompt. So here we've got a bit of a simple prompt of just generate a creative reason, a creative excuse, sorry. We then here do something that you may see in a lot of prompts, which is few-shot programming, where you give the prompt a couple of examples of it working correctly, or how you want it to work, and it's kind of like just giving the AI a bit of a sort of small training session to show how you want it to act. Then finally, you just give it your question here of, I missed the F1 final race. We take our prompt, put it into a function. Once it's in a function, that function then becomes invocable directly by the user, as here, that we take this function and execute it and pull back a result. So it gets sent up to the prompt, to the AI and rendered, executed. But it's also executable from our templating language. So if you want to embed stuff into your prompts, you can invoke functions from your templating language, or as I said before, it also makes it available for the AI to come back and say, I want to run that thing because that thing looks useful for whatever I'm trying to do. So when we've sent it off and it's asked for the response, it comes back with the excuse of, I was in hospital getting my brain transplanted. So yeah, just comes back with the same reason. So that's defining prompts inside strings, but we also allow you to define them inside files and read them out of files, and also define a JSON schema that you can put into your files that will allow you to then define the various settings that you need when you're calling into different AI services. And this is the example of where I say we can work across multiple AI services that you can then sort of define for different services what settings you want to use. So if your deployment's happen to use GPT-4, you could use those settings, GPT-3, different settings. So yeah, it could sort of allow you to mix and match different services. If you prefer, rather than having them in separate files or JSON, you can also put them, we also have it in YAML templating. And it's again the same setting, the same sort of settings format, just in YAML. But the prompt that we're building up here is trying to figure out what the intent of a user is. So we can see that we're going to give the AI two choices, two inputs of the choices the AI could return, and then we're going to give an argument of the request that the user has input somewhere. And these are going to get substituted into our template. So how we go about using these, we pull in our template from the file, create a kernel function. We're then going to define our inputs. So the choices that the AI can make is either to continue conversation or end the conversation. So if the user says like, oh, thanks, that's all, it'll be an end conversation. Build up our arguments via request and our choices, add them into the invocation, then again, send it and get our results back. So our templating language. So like I say, there's sort of two sort of key parts of this. One is the sort of variable, inserting variables, which I showed in the last one, where you can add variables onto as arguments, and you can define custom serialization. So you can define your type. So if you've got some kind of type that you've defined yourself, you can define how to serialize that to be written into a prompt. We can it also goes the reverse, that if you're returning something of a certain type, so if, for instance, if it's returning a customer object or something, you could then define a deserialization mechanism for reading that data out of the prompt. So yeah, the variables effectively, you got a serialization to and from prompt. And then we can also do the function invocation. So as I say, once we've created a kernel function, we can then invoke it from our template. So if we want something like the current date, we can go off and do a function invocation. If we want something a little more featured, we do have handlebars templating. So this is where we can do things like go through iterations. So if we give things like a list of few shots examples, we can iterate through those examples and build up a prompt with lots of messages that show the examples of the bot working correctly. And then we can again do function invocation here. So this is like doing a summarized conversation. So here, not only is this doing a function invocation, but there's then going off and making a call into AI again in order to pull back information. So this is making an AI call to go summarize the conversation that's been had with the user so far, insert it at this point in the prompt, and then go off and produce your answer. So yeah, this is just kind of what it all looks like when it's all been built up. It gives you your choices of continue and conversation. It's iterated through and generated the few shot examples of the user asking a question and the intent being divined by the AI. Add in our summary. So yeah, the user has asked the assistant to help them write an email to the marketing team. And then finally, what was the user's last message, and ask them for the intent. So far, I've been doing how to create a function from a prompt. So taking textual prompts and turning them into functions. But you can also use native Java code as a function and make that available to the prompt and AI to be invoked. So here we define an annotation framework where functions that you annotate with defined kernel will become available for invocation. You can add descriptions and names and types onto the annotations. You can describe your inputs. And one thing here is that it's quite important to get very good descriptions on your input, on your function descriptions and inputs and names. because ultimately the AI is going to make a decision whether to use those functions. So it's important, and you're going to be helping it if you give it as good a description as possible. If you give it the wrong description, don't be surprised if it invokes something that you don't want it to. So, going about using functions that have been defined on an object. So here we just say new text plugin. So this is our object that has a bunch of functions that have been defined on it. So when we create from object, we create effectively a collection of plugins. It sort of goes through that object and finds all of the functions available on it. And then we just add them into the kernel. So now they're available for invocation. So we can again do invoke async, then var plugin, define our inputs, and it will go away, do the invocation, send the result to AI, and pull the result back. One thing you may know is that we do most of our calls so far are async. This is primarily because a lot of these calls can take some time to come back. We did want to offer asynchronous interaction with the AI. But yeah, so frequently we do just end up blocking and just pulling back the whole result if we don't actually want to execute in that asynchronous manner. So finally on to doing a bit of demonstration of this in action. So because I play some role-playing games, I created a sort of demo that utilizes sort of the various functions of AI in order to sort of manage a campaign that someone's running. So although this is obviously sort of working on a game, at the end of the day, it is sort of just going about asking questions on your data, manipulating data. So these are sort of like all common tasks that you can do for business apps. Like we have almost the exact same app where we just change awk into customer, and things just seem to work exactly the same. So first is our sort of question answering. So here we can ask questions about our characters. So this is similar to the last one of we can ask it questions of has StreetDef been in battle? This does the similar search of all of our information here, of our inventory and characters and our player facts, have all been written up into the search service and then are pulled back and used in order to answer questions. So it says, yes, StreetDef has been in battle, and then gives the supporting evidence that it's found in the database that's most relevant for answering that question. So again, if you've looked at anything called something called embeddings on AI, embeddings is a method of taking chunks of data and creating numerical vectors based on them, and then two numerical vectors that are closer together tend to be about similar things. So effectively what we've done is kind of embedded and taken these things, turn them into vectors, and then compare them with the question of has StreetDef been in battle, and it pulls back, as we can see, probably the most relevant information. So the first thing this system does when it's trying to interact with the user is it takes the statement they've made and determine what is the intent of the user, what are they trying to do. So asks us, are they asking a question, action, request, event, fact? So then we can sort of dispatch to different activity depending on what the user wanted. So in the last example, it was a question. So it then went off and did the whole pull data from a database, ask a query, style actions. So then once it's figured out as a question, then executes the prompt of, yep, given the following facts, ask a question, gives other information like who the player is that the question is being asked about, and then uses the handlebars templating language to insert the facts that have been pulled back from the database. So yeah, when it's been rendered and the facts have been pulled back, we give it gives us given the known facts, has StreetDef been in battle, gives us all the sort of most relevant facts. Doesn't always get it right. Sometimes it says that someone lives in a forest, which I'm not sure is exactly related to being in battle, but these are the closest things in the database, the closest 5 bits of information. Another interesting thing is that I slightly messed up the prompt because the prompt doesn't quite make sense, where StreetDef is a fact about StreetDef, but despite the fact that I messed up the prompt slightly, it still managed to understand the meaning of what I was intending to say. So it kind of gives an idea of the sort of resiliency of AI to mistakes. So we've got the example of if someone just puts in straight up information in the box, it can figure out like, oh, that's information. I will note it down, write it into my database, and it gets added into the available information. So then, it could be searched for later for answering questions. So again, if you do things like you've got action items from a meeting or meeting results, transcripts, that kind of thing, you can write them into your database and have them searched later. If you're wanting back slightly more structured data, so so far we've been kind of returning almost quite sort of free-form text. But if you can define a JSON schema of something you want back, so in our case, we're going to want to get a character back, and we can define a JSON schema for what a character looks like. We can tell the AI what the schema of that looks like, and to, when responding, obey it. So here we're going to ask it to create a character, and we're going to tell it what our models look like, and it will go ahead and say, and generate it in JSON, and it will go ahead and bring us back a full JSON object that sort of defines a whole new character, so we can go ahead, parse that in serialization framework, and bring it back into our application. Again, we've got I didn't do it in this example, but we do have a framework for defining serializing and deserializing types that then will be able to, if you added a custom character type onto your kernel, it would then, you could tell it how to deserialize this information. As you can see, it sort of pulled it back, parsed it, and then got us all the relevant information in the UI. So, something I've sort of been mentioning is about the ability for the AI to make calls into Java functions, or call Java functions that, as I say, things that you annotate with the correct annotations then become callable by the AI. So when you set it a goal, it can then determine from the menu of functions that you've made available to it, which of those things can it invoke in order to achieve a goal. Obviously, you need to be somewhat careful with this about what you make available to the AI, and be careful about the inputs. So I'm not sure if the PR landed yet, but after looking into it, we are looking at adding hooks that are sort of pre-function invocation hooks and post-function invocation hooks, so you can sort of check out, sanitize, and sort of make sure that the function invocation looks same. But but yeah, I'm not sure if that's if we've gone and landed that yet. But anyway, yeah. So I can kind of show an example of how we go about tool calling. So here's to note is that this character has 3 potions. The next character, Gren, has 0 potions. So then if we give it the instruction of streetf gives Gren a potion. So we've not actually implemented any explicit transferring item code path within our application, but it's gone off and logged it. The character's lost a potion, it's down to 2, and our other character has now gone up to 1. So even though we've never defined how to transfer things, it's figured out how to do the add and remove invocations in order to achieve what it needs to. So then when we go and, for instance, say the potion's drunk and they're healed for 10 HP, go off and invoke it again. It's now figured it out, and the character's HP has increased. It was at 30, it's now gone up to 40. So what that has done is that we have sort of a character object that defines a whole bunch of functionality that can be performed on characters and in various things in the world. So we got things like remove item from inventory. So again, given a sort of description of removes the character item from the item character inventory, defined our inputs, defined item name, and then what happens is the AI goes off and says, well, I need to remove an item from one player's inventory and add it to another. So I'm going to first call this function, then call the add, and then when we went off and called the heal function, it then goes off and figures out what to invoke. So this is a sort of a thing of it can figure out how to sort of do more complex tasks based on the sort of more simplistic tasks that bits of functionality it has available to it. Another sort of interesting thing is that when you're asking questions earlier and putting it in, if you type it in certain languages, it will also respond in the same languages. So again, don't necessarily need to do explicit translation. It's just sort of comes for free. Sorry. So, one thing that is sort of quite useful is that you can define rules. So when your AI is evaluating how to achieve tasks and how to do things, you can define various rules. So, and these are done using natural language. So again, you don't necessarily need an expert in defining rules in a system. You can effectively just sort of allow users to build up over time instructions on how their system works and how they want it to act. So this is kind of a sort of a very simple set of rules that I've built up over time of how to achieve various things. So I've had to add things like, when a player drinks a potion, it's removed from their inventory because didn't necessarily at the first time figure out that, when you drink potions, they disappear. But yeah, you can sort of go away, build up these rules over time, add them into your prompt, the AI will figure out how to apply them. So one thing that you sort of may take issue with is that although annotating all of your methods is all well and good, it may pollute your code base and not something that you want to fill your code base with. Or you may want to make calls into other systems that are not written in Java, or you're just not able to annotate. So one thing you can do is that we've got available is OpenAPI plugin parser. And what this does is if you can get a OpenAPI definition of your API, it can parse that and then turn those into functions that can then be called. So here we've got the sort of example of a pet store where it's gone off, parsed the pet store OpenAPI definition, and then turned all of the functions, all those RESTful calls you can make into the pet store API as functions that the AI can now use. So we end up with a whole load of functions like, delete order, get pet by ID, that are all now callable. So now we can go off and do sort of natural language again, sort of questions that go invoke the various endpoints. So I can say, create me a user, and it will figure out how to go off and form this into a valid request that can be made into the create user endpoint. I can say like, create me a new cat, list all available pets, and it will sort of, figure out what methods on a RESTful endpoint, RESTful API need to be invoked. So, another one that we have that is quite interesting is the audio to text. We have both audio to text and text to audio. So if you have a recording of perhaps something like a meeting or chat with a user, so maybe if it's from a mobile application that you could get a user talking to it, like a Home Assistant, you can send it into OpenAPI, takes that, extracts the text from it that you can then obviously use in further prompts for extracting action items or trying to figure out what the user is trying to do. So here we've got the example of just create our audio to text service, defining the model that we want to use. We've got a binary file here, so it'll be the MP3 or WAV, I can't remember. Create our execution settings for that we want that this should be in English. You can then give it a sample prompt to sort of give it some information about what the recording might be. So we want our response back in JSON and then just various other settings. So we just do again get text contents from or get text contents async, go off, sends that data, pulls it back, and gives us the text. So quick example of this in use, what I added to our RPG application is that it's got the ability to listen to a user or to someone talking about the game, that it will then take what the user has said, convert it into text, then put it into a summarization prompt that will then go pull out the action items, and then do the sort of tool invocation to figure out how to apply what the user has said to the game world. So I must admit, I did not test audio, so I'm not sure if you're going to get audio here or not. Is it? No. Don't think we're going to get audio here, are we? Choose the speaker. She was going to say? No. Okay. Yeah, let's try and make it very loud. See if it's. Got one here if you want. Yeah, let's see if it. There's a channel we need to hear. If it freaks out, whatever. Let's see. Where is my input button? Okay, so let's see, is this going to work? Yeah. And Gren is healed for 10 HP. Ah. So, okay. How do I go back? Okay, can you try the microphone? See if you're going to catch this. No, you're not going to get it, are you? Okay. Streedef enters the room and sees Gren on the floor, badly in need of healing. Streedef gives Gren a potion, and Gren is healed for 10 HP. So yeah, just said that the character is healed for 10 HP in audio. No, it's a terrible demonstration. Their health they got increased, and you can't see it down there. But it's pulled back the log and realised that's what needs to happen. Pulled the action items out of the audio and performed them. So yeah, if you saw the character got healed up by 10 HP. So the idea of this is sort of kind of hopefully we'll be able to listen to a sort of transcript or listen to a game being played and sort of automatically update our environment. But again, this could be a meeting that it is listening to that you've probably seen things like meeting software like Teams will do automatic summarization of what people were saying in a meeting, that kind of thing. So you could do similar things via Semantic Kernel. And with the text to audio, if this is now going to go back, that's
Red now has 40 HP after being healed by Streedef with a potion.
So yeah, so it'll then do the opposite of text to audio, and so again, if you wanted to do something like a mobile app that was like a home assistant that you could chat with, that would be possible. You could do that via Semantic Kernel. So, just to wrap up here a bit. So, yeah, Semantic Kernel for Java. It's a Java 8 plus library. So it's available on Maven Central. So I'll link to the Maven coordinates in the next few slides. Currently, we have open AI integration, but we're working on adding more services. As I say, I've got in development a Hugging Face integration that's working well for text completion, but we also have people working on sort of Mistral and Gemini right now at the moment. And again, the idea will be once we have all of these services that you'll be able to sort of mix and match whichever service is best suiting your needs. We're open source up on GitHub. Should have the links in the next slides. MIT license. And we have samples available in 17 plus. And yep, so we would love to have contributions. So if any of you are interested in this, want to use it, want to come along and contribute, yeah, please come check it out. So what's next? I say we are trying to add the more AI services. That's kind of what we're sort of immediately working on right now. We're looking at upgrading our memory connector story. So the examples I've shown here where we're pulling data back from databases, in our release candidates, we had that as more formalized, but we weren't quite ready to formalize it for the V1 release. So now we've gone V1, we want to look into more formalizing how you go about pulling memory back from various databases. Currently trying to do more sample applications to sort of give people better idea of how they can go about using Semantic Kernel. And also image generation support is another thing that's sort of looking at adding. So I say the Maven coordinates there, Microsoft.com Semantic Kernel. We got some sample applications. So these kind of show our syntax samples of sort of quite simple things of how to use it. That's our open AI demo. Sorry, the earlier HR bot demo. Yeah, so again, you can go try it out and feel free to submit any pull requests. We're up here on GitHub. This in the Microsoft Semantic Kernel branch. Repo. Currently in a Java branch that we're looking to move that to a different location at the moment. This is the link to the Semantic Kernel demos. That's you believe that link? Yeah, that has the role-playing game example in that repository. Yep, and we've got some links. You can come join us on Discord. We've got a Java channel on Discord that you can come ask questions and talk to us there. And also we've got a booth downstairs, so if any of you want to sort of come talk about AI or any other information, you can come down there and talk to us. And unfortunately, the demo gods are not with me today for being able to set up a live demo of the RPG app up here, but I may be able to set it up on the booth downstairs if anyone actually wants to sort of come try playing with it. But yeah, well, thank you very much, and yeah, no questions. So, yeah, if anyone has any questions, I think we do have 3 minutes left.
I was just wondering if you can connect Semantic Kernel to local LLMs like Olamotion.
Yes. So we have had someone internally that ran it on Android, and they hooked it up to a local LLM. Yeah, I think was it Ulama they were using. So yeah, you can define a connector. So we don't have the connector written right now, but he sort of wrote that quite quick. I think it was like literally took him like a couple of hours to write a connector. So we don't have it out of the box, but it's absolutely possible. Yeah.
Yeah, kind of a follow-up question about the vector databases. What kind of databases are supported right now in the Java implementation?
So this is what I was sort of mentioning in the that we need to go formalize our memory connector story. So if you go back to the release candidates we had in that support of Mongo, SQL databases, the Azure Cognitive Search Service, and it's just going to be a case of moving those over to a formalized V1 spec. So it'll be pretty easy to do Mongo SQL databases or Azure Cognitive Search right now, and we should have that defined pretty soon. Yeah.
Okay, thank you.
Okay. Yeah.
So going back to the demo you had on the HR database, obviously one of the things we've seen with language models is that sometimes you can sort of make them make morally poor decisions. You can break the ethics of ChatGPT and get it to tell you how to do all sorts of horrible things. Is there ever like a concern as to, let's take a production example of a company with their HR data in a database like this. Are there mechanisms in place to prevent like privilege escalation or people, bad actors being able to potentially go and potentially break one of the existing rules that's been put in place?
Yeah, so Open AI itself has sort of flags on it that try to detect sort of types of behavior that you don't want. So it'll sort of remove things like or try to avoid doing explicit content, abuse, that kind of thing. So yeah, Open AI has those functions in place. So semantic kernel itself, other than the sort of the hooks that you could use to intercept calls, that you could then run it through sanitization steps. And yeah, particularly looking at things like sort of like you say, like prompt injection tech style, so you could then run it through various prompts to try to figure out, is this a malicious statement?